Alright, welcome to another AQA chemistry video. Today I'm going to be doing a video which is pretty much me answering questions. It's a question based off, it's AS, it's an A-level questions based off of AS content. This paper is 78 marks. Now I'm going to try and do this paper in under an hour. I'm going to leave a link in the description if you want to do this paper. You don't need my help, but just in case, if you look at this paper and say, oh, I don't really get how to do that, or what's the mindset of how you will go into this question. This is something I've done. I've completed my A-levels already in the summer, so I'm just doing this for the sake of doing it. And yeah, I'm gonna go straight into it. Alright, so I'm gonna set a time for 1 hour and 18 minutes. Probably can't see it because of the reflection, but that's 1 hour 18 minutes. I'm gonna try and do it in under an hour. Alright, yeah, so which molecule is not able to form a coordinate bond with other species? BH3, CH4, NH3. That can definitely do it, so no. It's got lone pairs, no. And I can't do it. Has boron got an extra lone pair that I can do? It's in group. Boron's in group 3. But carbon, I've never ever seen carbon with 5 bonds. So I'd say this one. That's hard between those two. Which species has a square planar structure? So I'm thinking about something with 6 bonds. Sulfur's in group 6. One, two, three, four. No, but XEF, that's 8. If I did XE, that's not, that's 6, that shouldn't be 1. XE, F4. That's 4, 5, 6, 7, 8, and I will give you a square planar structure, XeF4. Which one has most unsymmetrically electron distribution? This one. Oxygen's the most electronegative compound there. Alphone's there, so that's the most polar, the greatest difference in electronegativity. The more polar and more unevenly the electrons are distributed. Which statement about inorganic ions compounds is always correct? Always correct. They dissolve in water to give neutral compound. That's definitely wrong. Which they release energy with no. Energy goes in. They contain metal anions. No. They form a giant structure. Definitely. Which species has a lone pair of electrons on the central atom? Well, that's on group 6, right? So then sulfur's 2, 3, 4, 5, 6 lone pair of electrons. There you go, done. In which substance do covalent bonds break when they melt? Covalent bonds, that's not intermolecular. Silicon dioxide is a fully covalent compound. In which molecule are all the atoms in the same plane? C6H5CH3, C6H5. That's just benzene with one chlorobenzene. This one you probably don't know this one. You probably don't know this. If you did the AS content, you probably wouldn't know that one, but you'll learn about that one in year 2. Which molecule has a permanent dipole? This one should be this one. That's the most nitrogen is the most electronegative. That's hydrogen bond. That's covalent bonding. Which substance contains delocalized electrons? Graphite, easiest one there. Which polymer has hydrogen bonding between, okay, that's, if you know it, you know it. This question is about the shapes of molecules and ions. Draw the shape of NCl3 and NCl4+. I did say, I don't know if I remember saying it at the start of the video, I'm going to leave a link in the description to this exam paper in case you want to do it. It's on Physics and Maths Tutor, in case I forgot to say that. This question is about shapes of molecules and ions. Draw the shape of NCl3 and NCl4. So, it's group 5. Three, 4, 5. So then it will be NCl4. In the real exam, you probably get close to 190 minutes for this question, for this paper. But I'm trying to do a mark per minute. 1, 2, 3, 4. Hit 1, 2, 3, 4, and it's a plus, and then that's 5. So then remove that, and then it's just yes, this is exactly what I thought it was going to be. This is an ion. It's an ammonium salt ion. So name of NCl3, trigonopyramidal. Trigonopyramidal, yep. Trigonopyramidal. And that should be tetrahedral. Sorry for the background noise, but life is life. Explain the explanation of bond angle of NCl4+. So 4 bonding pairs, no lone pairs. That equally repel each other to be as far apart from one another as possible. So 4 bonding pairs, no lone pairs that equally repel each other. To be as far apart from one another as possible. Which compound contains a coordinate bond? This one. Right. This question is about pentantiol and pent-1-ene. Boiling point of pentantiol is 119 degrees Celsius. Boiling point pent-1-ene 30 degrees Celsius. Explain why pentantiol is. Alright, so an alcohol. First of all, I talk about what the compounds are. So pentantiol is an alcohol. And which has hydrogen bonding, which has stronger. The idea behind understanding that it's understanding what intermolecular bonds are forming. When you have an alcohol, you have that partially positive hydrogen atom because that's it's a small ion with high nuclear charge. Partially positive hydrogen atom and an very electronegative oxygen atom. Second most electric element on the Pauling's table, right? So you're going to get very strong hydrogen bonding. That's what causes this high Remember, that those intermolecular forces what cause the physical structures such as melting points, whereas pentanone has only Van der Waals intermolecular forces, which are generally much weaker. So pentanol is an alcohol which forms, make sure to say the word stronger, forms stronger hydrogen intermolecular forces, I should say. Between partially positive hydrogen atom on one pentanol and a partially negative oxygen atom on another pentanol. Pent-1-ene is an alkene with weak Van der Waals weaker. Remember here, stronger with weak. Make sure the part is important. Van der Waals intermolecular forces. I guess you could say that require little energy to break. Pentanone is formed by elimination of water from pentanol. So state the reagent and the conditions for this reaction. Outline the mechanism. So this would just be a hydration reaction. If you're forming... No, this would be a dehydration reaction. Dehydration reaction. So reagent, I'd use a concentrated acid, so it could be concentrated. State the reagent, so concentrated H2SO4. If it said name the reagent, you say I have to say sulfuric acid, but make sure it's concentrated H2SO4, or I don't know what other compound you can use, another concentrated acid. Conditions, hot. Does it have to be ethanolic? No, that's for elimination. Yes, no, that'd be for electrophilic substitution, I think. No, even the elimination, it can be hot and ethanolic. Usually, that's the one I know at least. I think for ethanolic for basic elimination. This isn't using a base, so just hot. Outline the mechanism. So going from we're going from what's it now? Pentanol to pent-1-ene. Sorry, my bad. Pentanol to pent-1-ene. Alright, so the acid will release a H+, right? It goes for a lone pair on the oxygen atom on the OH. That forms this intermediate here. Positive. make it very clear that you have that there. CH2, CH2, CH3. Once that goes, you have this intermediate here. Pent 1-ene. Actually, yeah. That would cause that bond to be stable. Yes. Yes, that makes sense now. CH2, CH2, and then CH3. Alright, so the melting point of XEF4 is higher than the melting point of PF3. Explain why the melting point of these two compounds are different. In your answer, you should give the shapes of each molecule. Explain why each molecule has that shape and how the shape influences the forces that affect the molecule. So you should shape, forces, okay, and then, okay, so that's fine. And then the last one is that XCF4 would have this square planar. So it has 4 bonding pairs and 2 lone pairs. So lone pairs repel each other the most. To be as far apart from one another as possible. Lone pairs repel. Lone pairs repel bonding pairs stronger than bonding pair repulsion. To be as far apart from one another as possible. PF3. Phosphorus is what, group 5? Phosphorus is in group, yeah, group 5. F3. 2, 3. So it'll be trigonopyramidal. PF3 is trigonopyramidal. has 3 bonding pairs. And 1 lone pair. Lone pair repulsion is the strongest. I should have structured this question differently. I should have done these two first, and then I could just say the same thing for both of them. Lone pair repulsion stronger than lone pair bonding pair. And bonding pair. To be as far apart from one another as possible. Also, you can write this as bullet points. I didn't have enough space to write bullet points, but you can write as bullet points. You won't lose marks for it. I haven't done this in quite a long time, so forgive me if I'm going a bit slowly for you. Yeah. XCF4 has a higher melting point. I believe XCF4 has a higher melting point because it just has a higher xenon just has such a high MR in itself, so then XCF4 has a higher MR, hence would have, actually no, XCF4 has, first of all, it has van der Waals intermolecular forces. But with a higher MR. And then say PF3 has, PF3 actually has it has a dipole, that permanent dipole as well, I guess you could, but it's not, the MR of XCF4 is so much greater though. XCF4 has van der Waals intermolecular forces, but PF3 has van der Waals generally. Usually they would give you more space in the exam or extra paper. Has van der Waals and permanent dipole. But XCF4 has a high melting point. Due to stronger van der Waals intermolecular forces. Due to higher MR. Sorry, my handwriting's kind of got bad there. Melting point, so I said PF3 has van der Waals and permanent dipole, but XCF4 has a higher melting point due to stronger van der Waals intermolecular forces, and that's due to the higher MR. Alright, so which bond angle has which has a bond angle of 109.5 degrees? Definitely not that, That's yeah, it's just that, really, yeah. This question is about compounds that contain fluorine. Sodium fluoride contains sodium ions and fluoride ions. Na. Okay. Well, explain fluoride ions. Okay, so fluoride fluoride F minus would have 10 because they both have 10, but F minus has a lower nuclear charge. say 2 less. F minus has a lower nuclear charge than Na plus, so its nucleus has a weaker electrostatic attraction to the outermost electron. Yeah, so F minus has a lower nuclear charge than Na plus. That's 1 mark surely. So its nucleus has a weaker electrostatic attraction to the outermost electron compared to Na plus. Surely that's 2 marks really there. I'll come back to this. I'm not entirely. I think that's 2 points in my opinion. I should have made 2 bullet points maybe. Physical structure and bonding, while the multiple sodium fluoride is high. Sodium fluoride has ionic bonding. And has a giant ionic structure. Giant ionic structure. With strong electrostatic forces of attraction between oppositely charged ions. Again, that's only 2 points I can see, but in case I'm wrong, I'll come back to that. Giant ionic structure, strong electrostatic force attraction between oppositely charged ions. I'll come back to that. I think that's just my 2 points there. The ion H2F is formed when hydrogen fluoride gains a proton, shown in the equation. Sorry, my phone's going off. Name the type of bond formed when HF reacts with H plus. This is a dative bond. This is making me think of a dative bond, but I'm not entirely. Wait, if you're going from fluorine, sorry, I'm not even concentrating. So it's really late. It's like 1 o'clock in the morning right now. So, you're going from fluorine. Oh yeah, it has to be. Yeah, no, it has to be a coordinate bond. Has to be a coordinate bond. Because a lone pair, you're donating a lone pair from the fluorine in order to obtain this the H plus. So because the H plus isn't giving its own bonds, it's a H plus, so it's a lone pair of electrons on the fluorine atom is shared to form a covalent bond with the H plus. That's how I don't know, that's how I'm saying it. Fluoro antimonic acid. Why did I decide to do this video at 1 o'clock in the morning? Anyway, fluoro antimonic acid contains 2 ions, SbF6 minus and H2F plus. Draw the shapes of F. Okay. What's Sp again? I thought Sp. Sp is antimony. Okay. Alright, so that's in group 5. One, 2, 3, 4, 5. I get the feeling that it's gonna just have that. So 1, 2, 3, 4, 5. But then it is 1 from here is 6 because it's a minus, and that's just gonna be octahedral. Again, if you just want to skip to the part of the video that's relevant to you, and you don't want to just watch me do this painfully in silence, you can just skip to the part of the video that's relevant to you. Yeah, it's a minus charge. Actually, I would just do a little, make sure to do that because it is an ion. Type of name, I'll do this first. Actually, name and shape, we know it's an octahedral shape anyway. Alright, H to Fook. Okay, awesome. Group 7. That's 1, 2, 3, 4, 5, 6, 7, 8. Because it has to get. Oh no. It's a plus charge, isn't it? So it's just get rid of these final 2. Yes, and that's just bent. That's bent. Darren bent. Hydrogen fluoride. If you out my previous video, should I leave a link should I leave a link in the description to the previous video? I just saw this and I realized bond enthalpy is it's not part of its energetics. I recognize this question from like when I was revising. That's why. Yeah. Well, if you watch my previous video, then you should be able to do this question. I'll leave a link in the description for this question, but I'll just do it anyway. Hydrogen fluoride reacts with ethine, I guess, shown in the equation. All compounds are in a gaseous state. Use data from the table above to calculate value for the bond enthalpy of CF bond in the product. So delta H is equal to the reactants minus the products. If we're doing the bond enthalpy, is always delta H of reactants minus products. You actually get a mark for this in the exam, you know. In a real life exam, they actually get a mark for just saying that. You don't always get a mark for writing your equation out, but in this case you do. You're trying to work out what the CF bond is, right? What this is here. So let's just write it. So this is minus 179, right? Is equal to, because that's what this is. 2 by 412 plus 837 plus 2 by 562 minus 4 by 412. Is that 1, 2, 3, 4, and then 1 plus 348. I'm going to call the CF bond X, or 2X, because there's two of them. You can just write 2 CF, but just for the, I always just write X for some reason. So minus 179 is equal to, and you have your calculator with you. $2,785 minus. You guys should be going much quicker than I do, because I'm just so tired right now. I'm just so tired. Minus 1996. If you add that together, 1996. So I added this all together. 2785 minus 1996 plus 2x. So minus 179 minus 2785 minus 2964. So minus 2964 equals to minus 1996 plus 2x, which is minus 1109. So I guess minus 2964 plus 1996, that's minus 968, if you plus that. So minus 968 is equal to minus 2x, because it's, remember, it's now, so now I've taken out the brackets. X would just be equal, if you divide both sides by minus 2, divide by minus 2, 484. 41 minutes left to do a bit more. Sometimes you just gotta motivate yourself. Or assess more multiple choice. Which substance has delocalized electrons? Didn't we do that question before? Anyway, which change occurs when water is vaporized? An exothermic no, definitely not. Intermolecular forces are overcome. Yes, I say just straight to that. Equivalent bonds broken. No. Which compound has the highest boiling point? Hydrogen bonding. Alright. This question is about structure and bonding. Draw the diagram to show the strongest type of interaction between two molecules. Okay. This is just going to be hydrogen bonding. Include all lone pairs and partial charges in your diagram. Okay. So, H3C. In reality, there is a little kink in this bond here, actually, so that's why I've done that. CH2, CH2, and CH3. Alright, so oxygen would have two lone pairs, first of all. That's you know what, let's just call it how it is. That's a shite lone pair. Rule it out. Get this out. I actually make this whole thing a little bit lower. I've still got 39 minutes left according to this, so Why can't I just stop doing... You know what? It's not even relevant anyway. Partially negative, partially positive, partially positive, partially negative. It probably wouldn't be in that direction. But anyway, we've done that. Got the charges, got the lone pairs. It has to be done by a ruler. And it's always a dashed line like that. And then it's another. And that is done. That's it. That's all you need to know. Alright. Methoxymethane is an isomer of ethanol. The table shows the boiling point of ethanol and methoxymethane. In terms of intermolecular force involved, splitting the difference in boiling point. Ethanol has strong hydrogen intermolecular forces, or hydrogen bonding. I say stronger. Stronger hydrogen bonding intermolecular forces. I don't know if I see between molecules. Due to I should say between partially positive hydrogen atom and partially negative oxygen atom. Which is stronger than weak van der Waals intermolecular forces between in methoxymethane. Alright, nearly there. 12 of 16, we're nearly there. Alright, draw the shape of PLCl3 molecules in the shape of a ClF4 minus. Include all the lone pairs and electrons that influence the shapes. In the PLCl molecule, the oxygen atom is attached to phosphorus atom by a double bond that uses 2 electrons of phosphorus. Alright. Name it shape. Suggest the following. It's just a bond. Okay, cool. No problem. Central atom is always going to be that phosphorus there. The oxygen is going to take 1, 2, 2 from the phosphorus, but 4 bonds in total. And then the CF3 is 1, 2. That's not very clear for the viewers that are watching this. I guess you know my point, but yeah, there you go. Alright, so 1, 2, 3, 2, 3, 4, 5. That's fine. We just know it's going to be a tetrahedral structure. That doesn't get you marks, by the way. That's just to help you. If you know how I did shapes of molecules before, and you're comfortable with doing this topic, then these type of questions aren't difficult for you. The actual marks come from this, just to help you work out doing a dot and cross diagram. But yeah, you won't get marked for that. But that's just, at least if the examiner sees that, at least he knows you know what you're on about, I guess. Or he can kind of see where you're going with it, but you won't get marked for that. group 7. 2, that's 4, 5, 6. Okay, and you get an extra electron because it's a negative ion. So 2 lone pairs. Oh, that's square planar. Yes, yes. If you want to know how I got this, how I know the names, you just need to know them off by heart. Unfortunately, that's a. You know what? I should just leave the rubber out instead of keeping going back and forth into my pencil case. Leave that. Take that out. 32 minutes left on the clock here, so, or 32 and a half, I should say. This is a negatively charged ion, so POCl3 tetrahedral. Square planar. Benjamin's missing out on the World Cup. Unlucky, mate. Bond angle to see 90 degrees. Between each one's 90 degrees. Yes. Alright, which is not responsible for the conduction of electricity? Sodium ions in molten, not responsible. That is responsible, so that's no. The electrons between layers, no. That does it. Bonding the electrons in a metal, they do. The lone pair of electrons in water molecule, no, they don't. They don't. You should know them, but I guess by method of cancellation, it does help out. I guess that's how I always do them. Alright, this question is about compounds containing fluorine. Draw the shape of a molecule of krypton difluoride. Including your answer any lone pairs of electrons that influence the shape. Name the shape produced by the atom in a KrF2 molecule and suggest a bond angle. Lol. I'm not laughing inside, I'm crying in the inside on it. Honestly, I promise you I am. This life, man, this dunya is crazy. Alright. If I'm doing a difluoride, krypton's it's a noble gas, so it's always going to be group 8. 2, 3, 4, 5, 6, 7, 8. 3 lone pairs, 2 bonding pairs. That's 5, so it should look more like should I say seesaw? Oh, it should. Okay, wait. It shares that shape, which is similar to that of trigonal bipyramidal. I remember this example. I don't know, I think this is linear. I believe this is linear. The bond angle, 180 degrees. I might be wrong on that one, but I think that's linear. There are 2 lone pairs on electrons on the oxygen atom in a molecule of oxygen difluoride. Explain why the lone pairs of electrons on the oxygen atom influence the bond angle in oxygen difluoride. Okay, oxygen difluoride. group 6. 1, 2, 3, 4, 5, 6. 2 lone pairs, 2 bonding pairs. So, I mean, it already says 2 lone pairs anyway, I've shown. And you already know it's 2 bonding pairs. I guess. Explain why the lone pairs of electrons of oxygen has influenced the pollen. The lone pairs repel bonding pairs, or repel each other. Lone pairs repel lone pairs stronger than lone pair bonding pair repulsion. And bonding pair repulsion. I mean, yeah, it's stronger than bonding pair repulsion. To be as far apart from one another as possible. To be as far apart from one another as possible. How does it influence it? Causing a bond angle, so causing a bond angle of there's two lone pairs, so and this would generally be 109.5, so I go from 107, so minus 2.5 minus 2.5 again, so 109.5 minus 5, 104.5 degrees. Oh, another long question now. Silicon tetrafluoride is a tetrahedral molecule. Deduce the type of intermolecular force in SL. Is it SL? I'm not even reading properly. Silicon tetrafluoride SiF4 is a tetrahedral molecule. Deduce the type of intermolecular forces in SiF4. Explain how this type of intermolecular forces arise and why there's no other type of intermolecular force exists in this sample of SiF4. Okay, well, it's a Van der Waals. It's Van der Waals intermolecular forces. Van der Waals intermolecular forces. So there's a temporary dipole. I say first of all that there's not great difference in electronegativity. Leading to a temporary I've literally forgot I was answering a question. I'm that bored of this. So it leads to a temporary dipole, which would I guess it would if this leads to a temporary dipole, it would induce induces a partial attraction. I say semi-attraction. I don't know what like the wording would be. partial attraction maybe. Because the electrons aren't evenly distributed, you know, so it's like it's great difference activity leading to temporary dipole as electrons are unevenly distributed. I'm just going straight from the DOM. This probably might even be incorrect. I'm going to go through the answers at the end. Distributed. Inducing. I'll come back to this one. Come back to that one. Which row shows the bonding in ammonium chloride? I should know that one, that previous one. I say inducing an attraction. What would I say an electrostatic? No, it's not. It's not ionic. Actually, no, it is ionic. So inducing an electrostatic attraction. Well, no, it would be inducing a dipole. It's inducing a dipole between molecules. I say between molecules. This is probably not wrong. Not right. Not right. I'm pretty sure it would be an electrostatic attraction. So I don't know, I'll go through the answers at the end. We still have 21 minutes, and I'm nearly done anyway. So, which row shows the bonding in ammonium chloride? Ammonium chloride. Dative, definitely dative. So it can't be that with that. Covalent, if it's covalent, it has to be that one as well. Ionic, I would say that. You could say it has got a Cr minus and NH. I would go for this one here. It has got some ionic character to it. It's obviously covalent. Which molecule doesn't have a permanent dipole? Easy. Because it's equally distributed, so it's not polar. And then give the meaning of the term electronegativity. Easy marks. The ability of an atom to attract an electron pair of electrons. To attract an electron pair in a covalent bond. See, told you. I knew this definition would come up. Alright, explain why permanent dipole forces arise between hydrogen chloride molecules. Rise between. Well, there's a great hydrogen and there's a great. First of all, I say there's a great difference in electronegativity. Yes. Yeah, I say great difference in electronegativity, which causes a polar bond to form. Induces I believe that's only one mark though. I could just say that hydrogen is like there's a great difference between, well, because hydrogen hydrogen is partially it's got a strong it's got a high nuclear charge or high charge density, which causes it to be partially positive. So there's a strong, but that causes it to be partially positive. So there's a strong attraction partially positive hydrogen atom and the partially negative, because chlorine is very electronegative. Because of the electronegativity, that causes this kind of chlorine to be more partially negative, and therefore the hydrogen atom will be more partially positive as well. And the partially negative chlorine atom. Oh, it's actually 18 minutes left and we've still got time to go and do this last bit here. Alright, oh actually there's some question we need to go back on it, don't we? Complete the table by naming the type of shape of each molecule. Place is taken in the final column. Alright. What am I doing? Silicon's in group 4. I could just say that's tetrahedral immediately. I don't need time. Tetrahedral. No permanent dipole. pH 3. Phosphorus is in group 5. I feel like it could just be trigonopyramidal. I think I could just say that right. 1, 2, 3, and then 4, 5, and then here. So trigonopyramidal. They should give you more space in the real exam. They'd usually give you a bit more space in the real exam too. Beryllium's in group 2, CO2, linear? I say linear. CH3, okay, also tetrahedral, unless I'm being dumb. I'd say tetrahedral. But this has definitely got a dipole, a permanent dipole. Yes. Is phosphorus, is it beryllium? No. Is phosphorus, it's just this one here. Because that one definitely is. I'll come back to that one. I don't think it is. I think I got this one right. Which is the correct crystal for the substance named IT in simple molecular? Yes. No. Sodium chloride. Not covalent ionic. No. Yeah, that's it. I don't forget. Is this a... Okay. Which compound has the highest boiling point? Hydrogen bonding. No hydrogen bonding. Hydrogen bonding. I think I'm right with that one. I might have to go back on that one. Alright, now we're done. We have 15.5 minutes left. Kind of, you spend this time going over your kind of paper if this is a mock or assessment. Alright, I said this one, right? So F minus is a lower nuclear charge than Na plus, so it's sodium fluoride contains explain why fluoride which loyalty. F minus is a lower nuclear charge. I could just say 2 less protons. Than Na plus, so it's its nucleus has a weaker electrostatic attraction to the outermost electron compared to Na plus. Makes sense? I'm happy with that. Explain in terms of structure and bonding why the melting point of sodium fluoride is high. Sodium fluoride has ionic bonding and has a giant ionic structure. Okay, strong electrostatic attraction between opposite charged ions. I say requires a lot of energy to break the bonds. That's probably what I was missing. This requires a lot of energy. Melting point, yeah, this requires a lot of energy to break the bonds, to break all the bonds. The belts. coordinate bond. I was very happy with this. Very, very happy. More than you believe. More than you believe. Green grass. It's kind of messy now that I look back at it. It's kind of messy, but not like number 10. Yeah, for a mock. If they usually give you a bit more space to write in the exam, or they can go over. But if I really cared about it, I can just kind of cancel this out and write stronger here and hydrogen. But I mean, your teacher would. Yeah, if it's a mock, they'll get it. They'll get it. Tetrahedral square planar 90-degree. I mean, I think this is good. This is very good. More than you believe. More than you. I believe that is linear. I think I have seen that's linear. Lone pairs repel lone pairs stronger than lone pair. Lone pair bonding pair repulsion and bonding pair repulsion to be as far apart from one another as possible, causing a bonding angle of 104.5 degrees. Should I say 2 lone pairs? Don't be scruffy like me. Don't be scruffy like me. Plan your, in the real exam, you get more time, more space to write your things. But also make sure if you have time. Like I realize I have 12 minutes. Don't spend too much time writing your questions. But if you find yourself like you're in a position where you've got a bit more time, it's kind of structure your thing a bit better, I guess. Like, this is one I needed to go over again. Green grass. Blue sky. Alright. It's a great difference in electronegativity leading to a temporary dipole as the electrons are unevenly distributed, including a dipole between molecules. Between, I guess, like surrounding molecules. Between surrounding molecules. That was pretty comfortable. I mean, I can cancel that out now. It's the ability of an atom to attract an electron pair towards its nucleus, and I should say towards its nucleus. Towards an electron pair. The ability of an atom to attract an electron pair towards its nucleus. I'll leave it as it is. There's a great difference in electronegativity which induces the polar. I mean, would it be wrong if I said that is what it's doing, really? But you're really fooling. No, I'm just gonna leave it as is. There's a great electronegativity which induces a polar bond. There's a strong attraction between the positive hydrogen atom and positive negative chlorine. Muchas gracias. Tetrahedral. But then if it is it can't a permanent dipole. But where? But I keep on thinking to myself that this is that one of these two is, but that's definitely not. That's most certainly not. I think this is right. I think this is right. If it's wrong, oh well. And that's it. 9 minutes 17. 9 minutes 17 on the clock. So 09:17 left. I'm gonna go through the mark scheme now. I should get like a green pen. I don't have a green pen, so I just have to go through it with my highlighter right now. Unless, do I really want to get a green pen? A green pen would be nice, or another coloured. This is Sharpie. The Sharpie might have to do. Sharpie might have to do. Might have to do me a job. Nope. I'll just stick with the highlighter. All right. Gonna go through. So question 1 is B. C-A, C-A. The examiner will just go through if they just look at it. You know what, I'll remove this now, I don't need the timer anymore. So BCA, DB, DB, 6s, D, so DCB, so D, CB, B, A. The shape should be like here, like this one here. So you get a mark for each structure. 2, trigonal pyramidal, pyramidal, and that's not me reading the question properly, because it doesn't say name of NCF4 plus. It's the bond angle, and a bond angle. See, I'm just not paying attention. This is why you do your exams when you're not tired. If you don't sleep enough in the exam, you'll get very tired. I'm doing this at, it's now 2 o'clock in the morning now. All right. Yeah. The bond angle is obviously going to be 109.5 degrees. As I said before, it's not in 3D. It's in 3D space, so it's not going to be between 360, but it's 109.5 degrees. 4 bonding pairs, no lone pairs that equally repel each other. That's to be as far apart as possible. So that part equally repel each other as far apart from one as possible. I guess because that's 4 marks for not me. I could have got 5 marks, but I actually took this seriously. NH4. What was this question again? Question 12 was D. Yes. Penton 2O. So the idea that penton 2O is stronger intermolecular forces. Penton 2O, stronger hydrogen intermolecular forces. That's a mark. Pentamidine has Van der Waals forces only, and you have to see it, the only part. Pentamidine, Van der Waals intermolecular forces, and then penton 2O has hydrogen bonds. I said hydrogen bonds anyways, I guess that's 2 marks. Alright, concentrate, and B, reagent is a concentrated sulfuric acid or concentrated phosphoric acid. So yeah, phosphoric acid was the other one, but you could have concentrated sulfuric acid. Hot, or you could say temperature range between 150 and 200 degrees Celsius. You can get away with just saying hot, so why run the risk. And then this is you get a mark for this is to give you more space, obviously. Mark for that, doing that one there. Suppose mark for this. When you go into organic chemistry a bit more, I mean these mechanisms are. I should have already gone through this, I believe. That high temperature reagent indicated as some way. Oh, I think 1, 2, 3. Cagliari from there. Where'd you get your extra mark though? One, 2, 3. Oh, and then having the structure, having the intermediate. That's okay. And then, all right, cool, no problem. That's 5 now because you have the one from before. All right. The next one is like a long 6 marker. Is it? Yeah. XCF4, 4 bonding pairs, 2 lone pairs. So stage 1. So 1A is just saying that XCF4 has 4 bonding pairs and 2 lone pairs around the XC. So that's 1A. to say you have to say around the lone pairs, so I should say around XE, but I just don't care anymore. 1B, PF3, saying that PF3 has 3 bonding pairs and 1 lone pair around the phosphorus. 3 bonding pairs, 1 lone pair. XF4 is square planar. 2A. PF3 is pyramidal. Strickland pyramidal. 2C electron pairs for, yep, I already said that the electron pairs be as far apart from one another as possible. XCF4 has van der Waals forces. Van der Waals molecular forces. PF3 has van der Waals molecular forces and permanent dipole, yes. So it has a higher multiple weight. So due to larger MR, more electrons or larger molecules packed closely together. So higher MR, X3 has a higher melting point. 15 is A. 16, fluoride ion has fewer protons or lower nuclear charge. So F minus has a lower nuclear charge than Na plus as marked, and is a weaker attraction to the nucleus and outermost electron. So weaker, you can say, attraction to outermost electron. Alright. Electrostatic attraction between oppositely charged ions. So there's a strong electrostatic attraction between oppositely charged ions. Lots of energy needed to overcome bonds. This is a coordinate bond. A lone pair of electrons is donated from. I should have said donated. I mean, is it? Do you have to say the word donated? I mean, it is donated. Lone pair of electrons on the fluorine atom. I thought about saying donated, but I was like shared because it's a covalent bond, but it is donated. You have to say the word. I mean, it's not underlined, but I would probably use the word donated. I won't say the word shared. I thought about using the word donated, but then I changed my mind. And that's because I'm tired. Guys, as I said before, do your exams, or make sure you get good sleep before your exams. You'll make dumb mistakes like this, things that you'll regret. Lone pair of electrons is donated. A lone pair of electrons on the fluorine atom is donated to form a covalent, what's this, dative covalent bond. To form a dative covalent bond, H+. But the important part is saying, not saying on, you have to say from. It's actually underlined saying from the fluorine atom. So yeah, that part there. But this part is fine. Octahedral, I mean, that's just 4 marks. And then this part, if you did everything, I mean, if you're able to get to this part here, you should have done everything else right. I mean, you do get a mark for saying this part here. If you done anything else, you've probably done everything else right, to be honest. Let's be honest. Yeah. 11 marks out of this. Solid performance. 11 points out of 13. Doesn't make any sense. Solid performance. Solid performance away from home. Say points like it's a game. Anyway, 17 A, 18 C, 19 D. These are easy marks. 20. I mean, they're only showing one bond here. But technically there's two. They're only showing this to here, but technically there's two bonds. I would talk to your teacher about this because technically they're only showing in the mark scheme one. That's what they're showing. Let me actually read it out, but because technically if you move this over to here, you can have another one between this one and this one. But ask your teacher about it. But from what I've understood, from my understanding of chemistry, you could technically form two. But if I'm wrong, ask your teacher about it. But that's how I was drawing it. But the idea of having the lone pair, you get the marks using the two lone pairs on the oxygen atom, right? The the broken line has to be straight as well. That's that. It's a straight, no, it's a separate mark having it as a straight line. So the first mark is for the two lone pairs on the oxygen atom, on each oxygen atom, and then for having the charges on each, the partial charges, and then the mark 2 is for having the broken line, mark 3 is for a straight broken line. I guess this part here about having two of them, be wary about that one. First one, hydrogen bonds, just mentioning hydrogen bonding, and then Van der Waals on methoxymethane. Yes, tetrahedral, square planar, 90 degrees. Bob's your uncle. He's not actually. His name is Jared. 21 is D. And this is right. Okay, this is right, and it's linear and 100. So that's part right. This is also right. There's one is it's the same thing. It's just that theirs is 90 degrees rotated to the left. But realistically, it's the same thing in space. It can be reoriented many times, but it's the same thing really. It's just this like that, but it's the same in space. It's the same thing. So correct. Lone pairs repel more than bonding pairs, so lone pair repulsion stronger than lone pair. I mean, you kind of already inferred that. Allow idea of reducing the bond angle. Van der Waals forces. Is this the second to last page? So uneven distribution. Okay, so I got the right part about saying uneven distribution, inducing a dipole between surrounding molecules. Neighboring another nearby surrounding. I'll allow that. Yeah, give me some of that, son. Give me a bit of that. That's only 2 marks though. And it's saying, I have to say the symmetrical molecules or dipoles cancel. So the third mark saying symmetrical molecules. / dipoles cancel. Two marks. Seven. 23C. That's correct. I'm happy with that one. 24D. These 1 markers should be easy to see. Isn't this repeated again? Oh no, I'm just losing my mind now. The ability of an atom to attract a lone pair of the power of an atom to attract a pair of electrons in a covalent bond. Yes. There's a great difference. I mean, this is just a mark. It's underlined. Great difference. Well, not great part, but difference in electron negativity leads to bond polarity, which induces a polar bond. I say leads to bond polarity is probably better saying it than induces a polar bond. Leads to bond polarity. I don't know if a teacher would give that, probably wouldn't. And then dipoles don't cancel, therefore the molecules has an overall permanent dipole, and there's but that's in brackets though. And there's there's attraction between the partially positive on one atom and partially negative on another atom. So a strong attraction between the partially positive hydrogen atom and partially negative chlorine atom on one, but I have to say on one molecule. So partially positive, strong attraction between partially positive hydrogen atom. And I know this as well. On one molecule and on another molecule. Okay, let's see. Let's go. Hopefully this is it now. I've been going on for quite a bit. Tetrahedral, trigonopyramidal, linear, tetrahedral, but this has to be, how is that a permanent dipole? Oh, do I even want to care about it? No. 3. If I do that, I'm just too tired right now, guys. Listen, do your thing, yeah, do your thing. A. I don't know how many. Do I really care about counting marks up again? I reckon I got a decent score, but hopefully this video helped. That's it.